The Trinity Test was the first nuclear weapon explosion in human history. How high did the scientists estimate the risk of triggering a chain reaction in the atmosphere and thus destroying the entire planet, as discussed in the movie Oppenheimer? We find out in this video, and there's also incredible original footage of the explosion, so be sure to stay tuned until the end. And if you like it, I'm galactically happy about a thumbs up and a comment, because that's how we get the YouTube algorithm to show this exciting topic to even more people. Thank you guys and welcome. This year, the movie Oppenheimer, which tells the life story of the gifted physicist Robert Oppenheimer, the father of the atomic bomb, was released in cinemas, and yes, the movie was met with rave reviews. Of course, I saw it in the movie theater, and I have to say that I wasn't so enthusiastic. I found the scientific aspects of the movie far too short. Apart from a few elementary school-level physics explanations, we don't learn what the scientific breakthrough behind the atomic bomb actually was. We see some of the most gifted physicists of all time, such as Niels Bohr, Edward Teller, Albert Einstein, but we don't hear a word about what exactly they contributed to the splitting of the atom. Maybe I just went into the movie with the wrong expectations and was a bit naive to expect quantum physics depth in such a blockbuster. I don't know. Please let me know in the comments if you've seen the movie and what you thought of it. I'd be extremely interested to know if you agree with my assessment, or if you say, "No Tim, you have no idea, the movie was brilliant." I did think about one aspect of the movie for a while afterwards. Between the physicists, the movie mentions the concern that a nuclear weapons test could theoretically trigger an unstoppable chain reaction in the atmosphere, which would ultimately have meant the end of the planet and our species. Today we know that this is not the case. Numerous nuclear weapon explosions, as unpleasant as they have been, have not set the atmosphere on fire in an apocalyptic manner. But why not? And how sure could Oppenheimer and company be that they would not destroy the entire planet? If they had, Oppenheimer's famous sentence would have been even more appropriate. Here is the original recording.
"Now I am become death, the destroyer of worlds."
The year was 1939. The Second World War was raging, and many famous scientists such as Albert Einstein, Leo Szilard, and Edward Teller had emigrated to the USA or fled. Many of these physicists thought it was possible that Germany was working on a nuclear weapon, an atomic bomb as we call it today, and therefore wrote a kind of warning letter to US President Franklin D. Roosevelt. In this so-called Einstein-Szilard letter, they warned against a German atomic bomb and demanded that the USA start its own program to develop a nuclear weapon. This ultimately led to the launch of the Manhattan Project, which was led by Robert Oppenheimer from 1942 with the clear aim of making the first nuclear fission discovered a few years earlier usable for military purposes, developing an atomic bomb and thus gaining an immense military advantage in the Second World War. To this end, Oppenheimer brought together some of the most brilliant minds of his time, probably even some of the greatest geniuses in human history, in a purpose-built research city near Los Alamos in New Mexico. In total, with logistics and all the trimmings, over 100,000 people worked on the Manhattan Project. And adjusted for inflation, over $25 billion were spent, an incredible sum. But when I think about it, Elon Musk spent $44 billion on Twitter, so he could have sponsored almost 2 research projects of this size. The Manhattan Project finally achieved its goal and resulted in the Trinity Test. On July 16, 1945, the first nuclear weapon explosion in human history took place a few kilometers away from the research city, in the so-called White Sands Proving Ground. Here you can see an original recording of the explosion in slow motion. How incredible that we have original footage of this at all, and how much you can sense the incredible power of this explosion. I thought it was very well done, by the way, because great care was taken here to create the original soundscape of an explosion, and the cinemas with a good sound system really put you completely in your seat. Here we see a recording of the explosion 0.025 seconds after ignition. Imagine that, the physicists involved in the Manhattan Project are standing there, waiting for the detonation, and couldn't be sure what was going to happen because, after all, it was the first nuclear weapon detonation ever. And there were serious voices in the scientific community at the time who thought it was possible that such a nuclear weapon would trigger an unstoppable chain reaction that would ultimately engulf the planet's atmosphere and destroy everything. So you're standing there, waiting for the explosion, thinking that there's a small chance that the end of the world could start now. Unbelievable. But why did some even think that was possible? The idea was this: the huge fireball, the huge nuclear explosion, just doesn't stop at some point. The nuclear chain reaction goes on, reaches the atmosphere, sets it on fire, and that would be the end of the world, as this chain reaction would never stop or only very, very late, as soon as the planet is destroyed. The famous German physicist Werner Heisenberg also initially shared this concern. We know this from Albert Speer's memoirs. Heisenberg had not given a conclusive answer to my question as to whether successful nuclear fission could be kept under control with absolute certainty or whether it could continue as a chain reaction. Hitler was obviously not pleased about this. Let's take a closer look. A nuclear weapon explosion is based on nuclear fission, the splitting of atomic nuclei, or nuclear fusion, the fusion of atomic nuclei. This is why there are two main types of nuclear weapons: atomic bombs and hydrogen bombs. Atomic bombs, as in the Trinity Test, use the nuclear fission of heavy atomic nuclei such as uranium-235 or plutonium-239. A subcritical mass of fissile material is compressed into a supercritical mass by ordinary explosives such as TNT. The critical mass is the amount of fissile material required to produce a self-sustained chain reaction. When the critical mass is reached, the atomic nuclei split and a huge amount of energy is released in the form of heat, light, pressure waves, and radioactive radiation. A hydrogen bomb, on the other hand, is not a nuclear fission weapon, but a nuclear fusion weapon. Here, the hydrogen isotopes deuterium and tritium are fused. Where do they get the immense energy required for this? Logically, through nuclear fission. In other words, a nuclear fusion weapon needs a nuclear fission weapon to go off. For us today, however, the nuclear bomb, the nuclear fission weapon, is relevant, as it was used in the Trinity Test and later in Hiroshima and Nagasaki. If a self-sustaining chain reaction is triggered in such a bomb, then it is not so far-fetched to think that this chain reaction could also capture further atoms and further, until the fission of atomic nuclei occurs at an exponentially increasing rate. Such an uncontrolled chain reaction would, it was feared at the time, have catastrophic consequences far beyond the vicinity of the detonation site. The hydrogen atoms in the atmosphere could become part of the chain reaction and thus trigger a global chain reaction, a nuclear firestorm. Physicist and Nobel laureate Arthur Compton, who was also working within the Manhattan Project at the time, said at the time, "Hydrogen nuclei are unstable and can combine to form helium nuclei with a large release of energy, as they do on the Sun. Couldn't the enormously high temperature of the atomic bomb be just what is needed to explode hydrogen?" And he then added a thought that makes my blood run cold at the very idea. And what about the hydrogen in the seawater? Couldn't the explosion of the nuclear bomb trigger an explosion of the ocean itself? And these horror thoughts don't just apply to hydrogen, but also to nitrogen, for example, which as a gas makes up 78% of the atmosphere. But the fact that you are watching this video, which I am very pleased about, and I am standing here, is relatively strong evidence that there was no atmospheric firestorm and that the end of the world did not happen. In Los Alamos, of course, they had meticulously calculated how high the danger of the planetary firestorm was. A report published in 1946 by 3 Manhattan Project physicists states, "It appears that whatever the temperature to which any part of the atmosphere is heated, it is unlikely to set in motion a self-propagating chain of nuclear reactions. It is impossible to reach such a temperature unless fission bombs or thermonuclear bombs are used which far exceed the bombs presently contemplated." And as we know today, even with the most powerful bomb in human history, we were far from setting the atmospheres on fire. The largest bomb ever detonated was the Soviet Union's gigantic Tsar bomb in 1961, which was actually powerful enough to shatter windows more than 800 kilometers away. It was 1,500 times more powerful than the Hiroshima and Nagasaki bombs combined, and the atmospheric firestorm did not materialize. Why? Why does the nuclear chain reaction in these detonations not continue indefinitely? We have already heard one answer, and it reflects the beautiful simplicity of physics very well. You can theoretically set the atmosphere on fire, but you simply need much more energy to do so. In the Trinity explosion, on the other hand, the energy loss was far too high for such a scenario. An enormous amount of energy was released, but this energy is emitted in the form of heat, light, pressure waves, and radioactive radiation. Even under the most extreme conditions, far more energy would be lost in the detonation of the bomb than would be gained, preventing a sustained chain reaction. In addition, the amount of fissile material was too small. A controlled chain reaction requires a certain amount of fissile material, known as critical mass, as we have already learned. However, even the largest nuclear bombs do not contain enough fissile material to reach the critical mass required for an uncontrolled chain reaction. Another aspect that has made the doomsday chain reaction impossible is the inefficiency of nuclear fission. Only a small percentage of the atoms in the fissile material are actually split in a nuclear bomb explosion. To sustain a chain reaction, virtually all fissile nuclei would have to be split, which is not possible in practice. Moreover, even if one could manage to build a gigantomaniacal megabomb with the perfect nuclear chain reaction, the conditions in the atmosphere would not exactly be optimal, since we have different densities, different pressures, and different temperatures everywhere. The atmosphere would be much better suited for a continuous chain reaction if it had uniform conditions everywhere. I know, it's pretty tough stuff, so here's a summary of the reasons why Oppenheimer and company didn't completely pulverize the Earth and no other nuclear explosion. Firstly, the energy loss is too great. Secondly, the amount of fissile material is too small. Thirdly, the chain reaction is too inefficient. Fourth, the conditions in the atmosphere are not optimal for a chain reaction. Most of those involved in the Manhattan Project must have been aware of this. Nevertheless, it is of course absolutely correct that the possibility was discussed and calculated. I mean, nobody wants to be the one who accidentally destroyed the entire planet. It doesn't help to say, "Oops, it was an accident." How sure were the Los Alamos physicists? Daniel Holes, a physics professor at the University of Chicago, puts it this way: "You don't often speak in certainties in physics. Physicists always speak in probabilities. If you haven't done the experiment, you hesitate to say, 'That's impossible, that will never happen.'" It was good to think about it. Now, instead of radioactivity, let's increase the number of subscribers to my channel. Because I know from the statistics that over half of the viewers of my videos haven't subscribed at all. But it's absolutely free. It helps me immensely, and you won't miss any new videos. So everyone press the subscribe button now. Thanks guys. Let's stay with particle physics, but switch to photons, the particles of light. The speed of light is the fastest thing there is. You often hear that, but is it really true? Why researchers want to break the speed of light in the laboratory, and how we can even build a light speed drive in this way. I have explained this to you in great detail in the video shown. Be sure to click on it. It's very exciting. And if you want to support my work, then click on the Astro Shop and get the shirts from the videos. Every purchase helps me a lot to continue the channel. Otherwise, I'd say see you in the next video. Take care, guys.